we got a problem here where they're asking us to find the greatest number of vehicles on a certain interval. Well, the greatest is the same thing as saying the max, and the number of vehicles in this case, they said, is given by n of t. So that means we need to find the max of n, but on a certain interval. Well, to do that, we're going to use the extreme value theorem, which says you got to plug in your endpoints, so in this case a and 4, and we also have to plug in whatever critical points we're able to find. So we're going to need to figure out what a is, and we're also going to need to figure out whatever our critical points are, and then we're going to plug all of those in, and whichever one comes out the biggest, that will be our max. So that's a absolute max, and that's our absolute max on this interval. So let's start with trying to figure out a. They're telling us a is the time when a line first begins to form. But if you look back here, they said a line forms whenever capital A is greater than or equal to 400. Capital A, that was our rate. So that means we need this thing to be greater than or equal to 400. But I can now put that minus 400 has to be greater than or equal to 0. So if I graph this in my y1 on my calculator, I can just figure out where that is above the x-axis or where it intersects the x-axis. So it's going to be a little bit easier when there's a 0 here instead of when there's a 400. Alright, so I got everything plugged into my y equals. The real question now is what should I put in for the window? Let's start by changing the window to have an x min of 0, and then the x max, let's say that that should be about 5. We know we're only supposed to really be going up to 4, but I'll give us a little bit of wiggle room. And then our y min and y max, let's set that equal to negative 500 and 500, just because we see the 450 here. Not perfectly calculating that, but let's just take a look at the graph and see if that's good enough. So it looks like it's getting us a pretty good image of what's going on. But we got to remember that we're interested in where this thing crosses the x-axis and where it's above the x-axis. And we're saying a is the time when a line first begins to form, but that will happen if capital A is greater than 400, and that'll happen if this is greater than 0. So let's try to figure out where it's 0. We can now just hit second, trace, it'll bring us to the calculate menu, and then we're going to hit 0. I'm going to put that arrow key to the left of that first intercept, and then we put it to the right, and it creates these vertical lines, and it asks us, do you want me to guess in this interval? So we're going to hit enter, and it finds it for us. It finds it to be 1.46 blah blah blah. So that is basically your A. We can say that our A is about 1.469. Alright, so now that we have that A, we can take the N, which actually has the A in it, and we can rewrite it so that way it starts with the 1.469. But we have to find the critical points of that. So let's look at what critical points are. We say that x equals c is a critical point of the function f of x if f of c exists and if either f prime of c equals 0 or f prime of c doesn't exist. So f prime of c equals 0, that's the one you're used to, but f prime of c doesn't exist while f of c exists. That is the one that's a little bit more tricky. It doesn't come up as often, but in both of these we need to figure out what f prime is, or in this case n prime. So to figure out n prime, we need to take the derivative of both sides here. But that's actually one of the parts of the fundamental theorem of calculus. That it essentially says that you can cancel out the integral with the derivative as long as you plug in this t where you see the x. So it's now going to be a of t minus 400, and that equals n prime of t. So now when we're talking about the critical point, we want to set n prime equal to 0, and we also want to figure out where n prime doesn't exist. But let's start by just setting n prime equal to 0. But we actually already did that because we already had a minus 400 in our y equals, and we had graphed it. And one of the answers for where it's equal to 0 is the 1.469. So that's our first value of t. But then we need to figure out what the other point is. So let's go to our 0 thing again. But we're going to bring the cursor closer to the other intercept. And when we do so, we get an answer of 3.5977. So we can round that a little bit, and we'll call it 3.598. So each of these are critical values. Now, ironically, when we're trying to plug in, a shows up not only as a critical point, but also shows up as an endpoint. So we don't need to plug it in twice, obviously. And as far as n prime not existing, well, we actually have a graph of n prime here because it's a of t minus 400, and it looks like it exists on the entire interval leading up to 4. So we're actually okay on that. We don't pick up any extra critical points from n prime not existing. So now all that remains is just plugging in our a, plugging in our 4, and plugging in the last critical point that wasn't already there, the 3.598, and we'll just see which one of these comes out the biggest. And then whichever one comes out the biggest, that will be our max, or in this case, the greatest number of vehicles. So let's start with n of a, which remember is really 1.469. But that means we're going to need to go to n of t, and we're going to need to replace the t with 1.469. So where I see the t's, I have to now put 1.469. But remembering a was 1.469. Ah, interesting. I have an integral from 1.469 to 1.46. Whenever you have the same number on top and bottom, that means you always get an answer of 0. So we've already got part of what we need here, but now we also have to plug in 4 and 3.598. So if I were to have plugged in 3.598, then that means that the 3.598 goes at the top. So let's put that up here. But then I still need to put a of x, but that's the same thing as writing 450 blah blah blah, and then minus 400. And of course this is just supposed to be an x instead of a t. And then the last one I'm going to have to plug in is going to be when I replace this 3.598 with a 4. So this one is n of 3.598, and this one is n of 4. Now I just got to plug both of those into the calculator and see which one comes out the biggest. And maybe 0 will be the biggest, but we just got to check all 3. So to plug these guys in, we have to hit the math button, and then we have to go down to option number 9. And I got to put 1.469 at the bottom of the integral, And then for the first one, it's 3.598. And then over here, I could type in the 450 blah, blah, blah minus 400. But if you remember, I've actually already got that typed into y1. So when I go here, I can instead just put only y1. Now, how do I do that? I hit the green button and then F4, and then it pops up y1 for me. And then I just have to put dx, hit enter, and round this to 3 decimal places. So we'll just call that one 71.254. Now we got to do the next one, which means we just got to copy this. Just hit the up arrow key, hit enter, it'll copy. But then we want to replace the 3.598 with a 4. And round those to 3 decimal places, which is actually just this. So now we got these 3 answers. Now, out of 0, 71, and 62, which one is the biggest? Obviously, it's the 71. Now, they said round this to the nearest whole number. So we're going to round that to 71. And we finally figured out the greatest number of vehicles on that interval.